Hello everyone, welcome back to this Beckhoff AX8000 motion control series video. In this video, we will discuss how can we tune the drive, velocity, and the positioning controller. And the velocity and the positioning controller we are talking in this video, we will mainly talk about the KP and the KV parameter inside the drive AX8000 side. The basic sequence, we will firstly tune the velocity, and then we will tune the positioning. This is the fundamental for the servo motor to do some high dynamic motion, especially in some cases if the drive system need to go back and forth for the velocity and the positioning, that control need to be very accurate. Alright, let's shift to the TwinCAT and let's go to the drive manager side. And to tune the servo motor, basically we will use the drive manager tool, this software. And I introduced how can we scan the I/O and how can we set up this drive manager tool, this project, and read the actual hardware configuration from the I/O area. And in my project, I have a channel A and a channel B. And now I'm double click this channel B. So let me use the channel B as an example. So if I go to the tune drive, at this area, you will see by default, your servo drive will be at this mode, cyclic synchronized positioning mode, CSP mode, means the velocity and the positioning control loop will be within the AX8000, the drive side. So basically, the NC axis will just send a command. Velocity feedback and the positioning feedback, they will all controlled inside the AX8000. So the default, that is a CSP mode. To tune the servo motor, we will start tuning the velocity control closed loop, and then we will shift to the position loop. So basically, we will shift to the velocity mode first, CSV. And after you shift to the CSV mode, don't forget compile the project and download active the configuration. Make sure this CSV mode was downloaded successfully in the drive. And after you download successfully, once you go online, so now I'm offline. So once you go online, you will see this area. Once you see this area got a disconnect, that means the drive is only running as the velocity mode. So make sure the drive firstly will run as the velocity mode. And the parameter we are going to tune, that is this, KP and the TN. And the main concept to tune the KP and TN, firstly, we will change this TN to a maximum value. Basically, we can see here, the max value could be set here at this TN, that is the 5 second. So we can set to 5 second. And then the KP, we will start from very small value, for example, 0.01, and increase this value, gradually increase the KP till we heard some noise from motor. We will hear the noise from the motor. That is the resonance from the motor. So basically, at that moment, we can write down the KP value. And then we can multiply 0.8 or 0.7 KP, the value, while the motor has a resonance. And we will use that KP value as the reference KP value. So this is the velocity closed loop gain, KP. After this, we can shift to the TN. We can start to tune the integral. The basic idea, we will start from the big value, then decrease the TN till the velocity steady state error got eliminated. That feedback velocity should track our set point very well. Okay, this is the basic concept or sequence to tune the velocity control mode. And after the velocity control loop, then we can start tuning the positioning control loop, CSP, positioning control loop. So we will focus on the KV after this positioning control loop gain. After we shift to the CSV mode, don't forget, click this active configuration, and you will see this two connection got connected. Position loop, we can change this KV. We can tune the motor from a small value here. For example, we can start from 1, and then we can increase this KV value. We can see that lag. The lag represents the difference between our set point, positioning set point, and the feedback set point. We can see the lag should be decreased. We can tune this KV parameter from a small value to a certain value. Okay, so this is the basic idea. And before we tune the motor, don't forget we need to go to the NC axis. So let me take this axis 3 as an example. So don't forget we go to the parameter here and go to the monitor here. Let's turn off this positioning lag monitor. Personally, I recommend we can turn off all of this temporarily. After all, the parameter haven't perfect yet. If we turn on this monitoring, the system will pop up the false, so we cannot tune the motor anymore. Highly recommend we turn off this. And don't forget, after we change the parameter, we will download the NC parameter right here. Okay? And to tune the motor, definitely we need to run the motor. Basically, to run the motor, we can use the NC drive. When we go online, we can power on the motor, right? So from here, we can power on the motor and then go to the functions. And we can select the reverse sequence here. From this output here, we can set the velocity set point, or we can set a percent value. And this target position, we can set a certain position and the velocity. And after we set this, once we click this start, so the motor can go back and forth using this reversing sequence. So as we can see now, the motor run in the 0 position and then go to 200. And once it's got 200 and then it going back. So the motor will go back and forth. Using this go back and forth while the motor is running, we can tune the velocity and the positioning closed loop. If you are using the curve or using the tune motor from the drive manager, you will see the velocity or the positioning will run this back and forth like this style. So meantime, you will see the set point of the velocity and the feedback of the velocity, the set point position and feedback position. When we tune the positioning, see, this is the positioning lag. It should be very narrow or very small. And this velocity feedback should match our set point. So definitely this motor haven't tuned yet. All right, let me go to one record video when I was doing the test. Let me show the motor tuning process. All right, in this test, I'm using the channel A connecting AX8000, this drive. And this link to PLC, I temporarily take this variable, take off that variable. So we can flexible to enable the drive or drop the drive at Drive Manager 2, that software. Now, compile and download the hardware, active the configuration. And then let's go to the Drive Manager here, the Tune drive. So currently, I'm setting the CSV mode at first. So we can see this positioning controller in the drive, it got a disconnect. So we will start from this default, this KP, this value. And before we tune the velocity controller, we will set this Tn to a maximum value and start from the small value at this KP. Then we can shift to the velocity controller at here, so we can directly change this KP and Kn. And now we are running as the CSV mode, and we active this online, and we can use the jog. So in this video, I'm using the jog to control the motor forward or reverse. That's because usually if the motor disconnect with your actual load, you can do the reversing sequence, go back and forth. But once your motor connect with the load, most of the cases, it doesn't allow you to do the motor back and forth frequently. The only way probably you could do is jogging the motor, just to do a slow move, so we can monitor the speed and the positioning. Therefore, in this video, I'm using the jog mode to move the motor. Okay, this motor, I can control this motor moving. So now I'm going to tune the parameter. So firstly, make sure this KV is 0. We can click this Control Enter, download the parameter. And this Tn, I can set a maximum value. The maximum value at here, the value is 5, 0 to 5. So I need to change to 5. If we set higher, the system doesn't allow us to set a value higher than 5. Okay, click this Control Enter. We can download the parameter. So we start from this 0.03 at KP, and the Tn, I set the maximum value 5. Okay, we can click As we can see here, the system has a big lag here. And likely the side point and the feedback, this is the velocity, it has a gap here. So this KP could be set higher. Okay, we just actually set this KP to a certain height. It starts from the 0.01. We set a little bit higher. So we can increase this KP till the motor give us a resonance noise. Alright, to tune the velocity, so we can take off others. For example, we can temporarily take off this lag, only leave this velocity, so we can clearly see this side point and the feedback, the gap between the side point and feedback. Okay, so now if we start from the 0.01, we can see when the KP is very small, we can see the feedback is showing the fluctuation here. And then we can increase this KP to 0.03. And we can compare the difference. Now, click this jog. So we can see this fluctuation got a better controlled, while the KP got a little bit higher. Then we can increase this KP. We can see it getting better and better. Now I'm going to increase this KP from 0.05 to 0.1. Increase a little bit higher. And let's see what will be changed. We can see once I set 0.1, you can hear the motor. And then I turn off this enable. And let me decrease this KP to 0.05. Okay, Control Enter and jog. Enable the drive and jog. And now the resonance disappeared. So the maximum KP roughly that's around 0.1 to 0.05. Roughly maybe 0.06. Based on my test, once this KP greater than 0.6, the motor will have the resonant. So I will use this 0.6 as my base, as my reference, and then multiply 0.8. This multiply 0.8 basically comes from the experience. So starting from this value, the KP, we can multiply 0.8. So eventually the KP would be 0.048 or 0.05. So we can time 0.8 based on this maximum value, while the motor just starting making the noise, that is the resonance, the status. And then this velocity integral, this Tn, decreases Tn to a certain value. The aim is to make this gap become smaller and smaller. So I'm picking another video as a short example. Here we can see the KP is setting as 0.064 and Tn that's starting from the 30. And now if we decrease this Tn, we can see the difference. And we can start from the 30 at first. So we can see at this parameter here, the motor velocity closed loop is running this style. And now if we decrease this Tn from 30 to 20, so we can see this area become better. Then we do one more decrease. And once this Tn change from 20 to 10, so we can see this vibration and this gap become much smaller. So once we decrease this Tn from 30 to 20 to 10, decrease this Tn, we can see this velocity feedback become much more better than before. So this is the basic concept or sequence to tune the velocity closed loop. We increase the KP first, and after the KP got the resonance from the motor, and we multiply 0.8. After that, we decrease the Tn. Okay, this is the basic idea for tuning the velocity closed loop. Alright, now let's shift the drive to CSP mode. Okay, and after change, don't forget, build the project and let's download active hardware configuration. And we can watch carefully about here. So after we download successfully, this area will show the online status. So we can see it become black So the system got started. We can see here, so it got a refresh. When the motor is running as a CSP mode, the closed loop, this controller is within the AX8000 drive side. So these lines are connected. So now the motor is running at the CSP mode. Alright, let's enable the drive. So let me jog the motor. Okay, we can see. Now we are going to tune the positioning closed loop. We can see the lag is so high. So definitely this P parameter for the positioning controller, we need to tune that. Okay. Now let's go to the tune drive. Here, let's increase this kV. We start from 1, let's change to 5. Increase the kV. We can see this value here. Definitely that lag become much smaller than before. Okay, now this kV is at 5. And at this area, that kV was at 1. And at this area, that kV is 5. So we can see after the kV got higher than before, this lag definitely got much better than before. Okay? This closed loop. If we double click this positioning controller, we can see the inside, what that looks like. And now this kV is 5. Okay? And as we can see, from this positioning loop, it also have this feed forward velocity. We can also tune this feed forward velocity. But now we are focusing on this kV. For the positioning control loop, basically we won't touch the T here. We only change the kV, this gain parameter. Okay? And now let me change this kV to 8. We change from 5 to 8. We increase this kV positioning controller gain. And then let's jog this motor again. Re-enable and jog it. Re-enable. And I'm jogging this motor now. So as we can see, if we compare this lag, the kV was 1, and this area, the kV was 5, and this area, the kV is 8. So basically we can see, while the kV parameter got an increase, so this lag become much smaller than before. So basically, while the kV is equal to 8, probably fit for this system, that makes this lag become much smaller. While we are tuning the positioning loop, this lag is very useful. Alright, this is the tuning the servo motor I would like to show in this video. Keep in mind, firstly, we will shift to the CSV mode, velocity mode. We will tune the KP and the TN at first. And then we shift to the CSP mode, allows the motion itself running as a positioning loop, CSP. And then we increase this kV from very small value to higher value, monitor the positioning lag. Alright, this is the tuning the motor. Basically, this is a rough idea. How can we tune the servo motor? In the practice, other than the motor running the high dynamic, we also need to trade off the mechanical. Because some cases, if the motor running too aggressive, maybe your mechanical, the lead screw or some gearbox, it doesn't like this motor running too aggressive. So you need to trade off the motor performance and the mechanical. So eventually you need to get a better performance of this entire, the servo motor entire motion system, right? All right, this is a rough idea and the rough procedure to tune the servo drive system. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.